And when you have different interval, you pick arbitrary testing point, and create a table either way. Some students prefer plugging in directly in the spreadsheet, or no, I prefer factor by factor, que es easy, no necesary calculator, and you determine the sign. Okay? When you determine the sign, que es the important information, you determine what is the solution set. Let's practice. Let's practice today a lot of example of this, and I want to cover now some special cases because in the last class I explained something weird. It is when you have one factor whose exponent is even 2, 4, something, you can ignore this. And this is not exactly 100% true. I want to explain it now when you delete or when you partial delete. Okay, I bring an example. I explain letter by letter. Any question, let me know. Suppose this elementary example, x minus 5. Suppose x minus 4 squared. Suppose I did the job of factorization. So you receive one complicated inequality, you move everything to the left, right hand side is 0, nice. Yeah, I did the factorization. I did that. This is not my issue now. My issue is understand this. You see, wow, look at that. This exponent is even. If when exponent is even, we can delete. And you convert this inequality and this inequality. You ignore this. Okay, and this is equivalent. The reason is clear because this guy always is 0, is always, sorry, positive. But when you have factor que is a square, never is negative. So non-negative, non-negative. Non-negative, it means positive or 0. According to this idea, obviously, this is totally irrelevant. You totally delete pam pam, and we convert my problem, my complicated problem. And suppose you have no ones, you have several factor que is square for the even number, you delete everything and keep only the factor que have the exponent odd, maybe 1, maybe 3, maybe 5. And you focus in this elementary inequality, que is x greater than or equal 5, and you express that answer in interval notation. Always the final answer in this problem, we express in interval notation. It is bracket 5, comma infinity. Do you understand very well this or no? Yes, okay. Suppose, and this is only happening when the inequality is greater than or equal to, no. Suppose the same inequality, but now it's less than or equal to 0. Same thing you are doing. You ignore this guy, you convert the problem in this, you solve that, but in this case it's in opposite direction. Entonces, from negative infinity to 5, bracket. That was bracket. One special. This is a special case you need to be aware for solving this. Now I want to complicate a little bit. Everyone follow me so far? Sure?
Yes.
Okay. Suppose this. Number 3. Suppose we have x minus 3. X minus 4 again squared. But greater than 0. So the only new thing bring me this new example que I delete equal sign here. So in this case, you don't totally delete, you partial delete, partial. No, I forgot spelling here. Not good. Partial delete. Why partial delete and not totally delete? Because suppose at x equal 4 is the number when you plug it in inside the parenthesis and the square and the fact that pretend delete. It's obvious that 4 minus 4 is 0 and 0 squared is 0 and 0 multiplication by any number is 0 and 0 is no greater than 0. You have contradiction. Okay, so now you can delete, but not totally. You can delete partially. Therefore, you partial chunk, you copy x minus 3 greater than 0, and you introduce restriction because this considered like a whole. X no 4. And where come from this 4? Well, no, it's the 0 of the factor que you have a square power gets the factor que you can delete. That this now is completely equivalent, 100%. This and this, including like a compound inequality. Oh, entonces it's easy, but you solve this inequality is x greater than 3, and this inequality is this piece and this piece together represent, let me see how, represent that's always happen. You solve the compound inequality, you ending graphically. This is my all real number line. Infinity positive, infinity negative. This is 0 in the middle. We have 4, 1, 2, 3, 4, and 3 is here. This is greater than 3, so that piece is that piece. Yes, I put it here like auxiliary. After when I finish, I highlight strong on the real number line. Of course, here is parenthesis, no bracket, because no equal here. But in 4, we have a whole. Okay, so actually, my answer is from 3 to 4. Of course, no include 4, because in 4 is no equal, it's a whole, and for 4 to infinity. Okay, and continue forever in that direction. So what is the final answer? This and this is equivalent to say parenthesis 3, 4 union, because it's two pieces separately by whole, and 4, infinity. Do you understand this or no? Yes or no?
Yes.
Okay, so keep in mind that we have two situations. Okay, we can summarize to say that when the inequality contain equal, 100% guarantee you que the factor que contain exponent even, maybe 2, maybe 4, maybe 6, you can totally delete. However, when you have no equal, the factor que contain exponent 2, 4, 6, even exponent, you partial delete. And how you partial delete? When you copy the other factor, they have exponent odd number, exactly the same. In this case, only one, but in one general problem, not necessarily it's only one, it's maybe 2, 3 factors. But the factor que contain exponent 2, you consider like this restriction. Like this restriction. And in this moment, you convert your problems, and actually, the original problem that we have is this, is non-linear inequality, non-linear inequality. However, you convert to one linear inequality, linear, degree 1, but this is compound inequality, so two inequalities separated by conjunction. Okay, not bad. Similar situation happen when you have, for example, x minus 3 or minus 5, sorry, x minus 4 squared. I copy always x minus 4 squared, but in general it's x minus something squared, less than 0. This is equivalent. This is the same thing. You understand, wow, this guy is cancel out, is delete, pero partial. You copy x minus 5 less than 0 and no 4. Okay, we have compound inequality. The rest is easy for us. Analyze graphically. Okay, infinity, negative infinity, 0. I solve for this case. Obvious is x less than 5. 1, 2, 3, 4, 5, and 4 here. Entonces es x less than 5 is that part. Or not include 5 because I don't see any equal sign here. No, this endpoint is not inside the solution. And 4, again, we have a hole. Therefore, my solution is, again, two pieces. That piece, small piece, and this is big piece, is infinity, by the way. So the answer is from negative infinity, 4, positive 4 gets this, union 4, 5. Final answer. Good. We have another, well, we have several, but we have another important special. Is, for example, you have, suppose you have x squared plus 4 and x minus 5 less than 0. Okay, this is different. Why is different? Let me try to explain the best way possible. Okay. How you explain this? Suppose the factor, I need to understand the difference between the factor x minus 4 squared and the difference between the factor x plus 4 squared. Okay. This is come from the parabola. The parabola that everyone knows, x squared, y equal x squared is a parabola like that, open, over like that. However, using transformation, this factor is horizontal shift 4 units to the right. 1, 2, 3, and 4. This is my new parabola corresponding with this expression. It's obvious, look in this graphic. This is x-axis, this is y-axis. It is always, this parabola is positive and 0, including 0. That is the reason que si our inequality contain greater than or equal, es obvio que es complete delete. Because remember, in the inequality, the important information we need is the sign. I don't care the value, I care the sign. And in this case, no. In this case, different. Look at that. In this case, it's a parabola also, but this parabola is vertical shift. And vertical shift 4 units over. 1, 2, 3, 4. This is my parabola. And you see, okay, this parabola always is positive. Never is 0. In this case, yes, it's 0. In this case, no, it's not 0. Therefore, See, this guy is always positive 100%. This is completely irrelevant in my inequality. Remember, when you are doing this table, the important information in this table is the negative. So you have two negative is positive. You have one negative is negative. Okay? So you have several negative, and this amount of negative is even is positive. See, it's odd and negative. So this is always positive, never zero. Now this no, this is change. Maybe it's positive or maybe it's negative. Maybe it's positive or maybe it's negative, depending on the value that you plug in here. Now it's obvious in this case, totally delete. Do you understand why? And you copy x minus 5 less than 0, independent if you have equal sign or no. Because this parabola is okay, or this factor in general is always positive. In this case, no. In this case, is well, almost always positive, but at x equal 4 is 0. That is a reason que es partial delete. Entonces, to solve this equation, super easy. You convert the problem in one linear equation. You delete totally this, delete. And x less than 5, and less than 5 is similar to this, is from negative infinity, comma 5 parents. This idea is clear or not? Tell me, guy. Because it's confused. I know, because it's partial, it's totally okay. I have another confusing example like that. Look, suppose example. This is a special. After I want to include it in the example, a collection of the another special. And be careful with the special. Suppose 3 x minus 4 squared is greater than or equal to 0. What do you think about this? Suppose in the test I put something like that. Boom. You see, one professor, this factor contain even exponent. And even exponent always is positive or 0. And 3 is 3. 3 is a positive number. And then, entonces, independent of the value that you plug in here, okay, this guy is positive, and this guy is also positive, que es equivalent to this idea, no? Positive times positive is positive, and positive is equivalent to C is greater than or equal to 0. Well, it's actually is no positive, it's non-negative. O sea, es positive or 0. Or 0. Que es exactly this idea. And then, entonces, this inequality, the solution is all real number. There are no number que when you plug in don't satisfy this. So all number, positive or negative. Suppose que I plug in negative something. 3 times negative 4 and negative 4. Negative 4 and negative 4 is negative 8, no? 3 times negative 8. 0 negative 8 squared is 64 positive. And 3 times 64, of course, is greater than or equal to 0. So the solution is all real number. Entonces, I illustrate two new things. Number one is the factor que contain even exponent. You know que es totally delete con this equal. But the 3, que es a number, you again totally delete because 3 is positive. Entonces maybe the question que fly in the air is, well. ¿Y si es negative 3, professor? Suppose the same example, but I put negative 3. This guy is always positive. And this guy is always negative. and negative. And positive and negative. And negative is greater than or equal to 0. This is completely false statement. That means there's no solution. No solution. No solution. No solution. So what is the conclusion? When you have inequality, and this inequality contains a number, because in the algebra, you manipulate, taka, 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 suddenly happen, you have one number. See, this number is positive, delete. See, this number is negative. Not necessarily always is no solution, because depending, suppose que es negative 3, and we have x minus 4, no square, like that. Entonces es obvio, que you can, for example, you can manipulate. How you manipulate? You manipulate divided by negative 3 both sides. Entonces es x minus 4. And when you divide, you know very well, when you divide inequality or multiply inequality by negative number, you reverse it. So x less than or equal 4. So basically is from negative infinity to 4. Bracket here because include 4 and balance. This is the answer of this. Okay. So the conclusion, the super fantastic conclusion is when you have factor that contain exponent even and my inequalities contain equal, is greater than or equal or less than or equal, you totally delete that factor. And you convert your complicated problem in one easy problem. They contain one factor or two factors, depending, no? Depending on the problem. However, if you have, again, one inequality that contains factor with the exponent is even, but the sign is not equal, sino it's greater than or less than, so you partial delete. Partial delete means that you include this like a whole, like a restriction, and you convert your problem in one compound. Okay, now, the weird factors, the weird factor like that, que it's always plus, no minus, and it's a square, que always is positive, like that. Now the graphic of this look like that. So you totally delete. And the numbers. Not necessarily 3, 20, 100, 5. Si the number is positive, totally delete. If the number is negative, no. The number is negative, you divide by these factors, both sides. And you continue the factorization. Let's do in one problem que somehow summarize this idea plus the idea that we covered before, right? Okay. So far, any question? No? Erase the board? Yes? Good. Okay, let's do in this problem. Suppose que it's given inequality like that. I skip the complicated word in which I need to bring everything, suppose in one problem, no? And to the left, because I need right hand side 0. Remember, this is super important. Right hand side of this inequality must be 0. Just in this moment, you see, wow, this factor look like similar to the factor that the professor explained that we can totally delete. Always. It doesn't matter que es greater than or equal or greater than or less than or equal or less than. In any scenario, this is because this guy is positive. And remember, the positive is not important in the solution for the inequality. The important is the negative. And you copy now x plus 6, x minus 7, greater than or equal to 0. End the story. End the story. You delete, totally delete that factor. We focus it. Okay. Remember the standard procedure. You copy this factor again. You enforce it to be 0 because this allow me find the critical value. The critical value are minus 6 and positive 7. This is our critical value. Cool. Using the critical value, I split, I make partitions of the all real number line. This is 0, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, and minus 6. So we have partition and minus 6. Let me using another color. And in 7, we have partition. Cool. I pick totally arbitrary testing point. Suppose minus 7 is good. 0 is super good. I like 0 because it's easy. And 8 is super good. And we create the table if you want or not, or plug it in directly. Testing point, negative 7, 0, and positive 8. And you evaluate, of course, and the factor que stay is x plus 6 and x minus 7, and you could attach extra column, que is the important column, total, in which you summarize everything. This is negative, obviously, because negative 7, so you mentally, you plug in this testing here, minus 7 plus 6 is negative 1, no? But I don't care the value, I care the sign. And negative 7 and negative 7, of course, negative 14, and 2 negative become positive when you multiply each other. 0 is positive, 0 is negative, and negative. And 8 is positive, and positive, and positive. Look, I close the column total because this is important. Because our problem is greater than or equal to 0. And this is equivalent in my mind to be positive. Positive or 0. So this is true. This is true here. And here. And this is completely false. You can write false, but I don't like. Because the important information is the truth. Because the truth is the solution. And you highlight this interval. So negative 7 pass. It is. Positive 8 is 0, no. 0, no. The 8, yes. Of course, you highlight the interval from the endpoint, is the critical value. Because the testing, the testing is one guy in the middle of this interval can give me the information for the behavior. Same behavior you can obtain if you have negative 8 or negative 9 or negative 100 or positive 8 or positive 9. So now it's not important. Now I highlight. Okay, include or not include the endpoint. Include 6 and 7. Of course, yes, include. How do you know? Include because it's equal. But the endpoint, the critical value is inside the solution. In this case. Always happen, but in this case, yes. What is the final answer then? Answer is from negative infinity, comma, negative 7, negative 6, sorry. They made the same mistake of the students. Believe that the interval ending in negative 7, no, in 6, bracket, union, bracket 7, comma. Final answer. Do you understand very well?
Yes.
Cool. No question? Okay, so let's move in now to rational. A rational is very, very similar, except irrational is, polynomial divided by another polynomial. So I want to complicate a little bit your life now because we have rational. And rational, remember, by definition is division to polynomial. So this is elementary example. No. To start this, I don't want to complicate too much this. Because somebody do the job, not me, I appreciate so much its help, are doing the factorization. Somebody do the factorization of the polynomial at the top and do the factorization on the polynomial at the bottom. Cool. Entonces I need to find critical value for the top, critical value for the bottom. Okay. And you take the polynomial at the top, you enforce it to be equal to 0, and you obtain at x equals 0 and x equal 2 is a critical value. Critical value of top. And it's important to say this last name, critical value of top, because somehow happen the behavior is a little bit different. And at the bottom, we have x minus 1, x plus 1 equals 0, and that means x is 1 and negative 1. And this is the collection critical value of bottom. Okay. Now I go to the all real number line. I go to the all real number line. And I do partitions using all critical value. How many? We have 4. 1, 2, 3, 4. See, we have 4 critical values. We have 5 intervals. And you need to testing 5 intervals. Okay, no problem, I understand. 0. 0 partition. 2 partition. 1 partition. And negative 1, another partition. 4 partition. 5 interval. Okay? And you pick, select, totally arbitrary. So another student select different like me. No problem. That the answer doesn't change. For example, good testing is negative 2. Another good testing is negative 1/2, because in between 0 and negative 1 and negative 1/2. And here positive 1/2 maybe is good. And here 1.5 or 3/2, either way, fraction or decimal, 1.5, 0.5, negative 0.5, and 3. Okay, 1, 2, 3, 4, and 5 testing, because we have 5 intervals. Okay, I need to verify if the inequality solution or no in each interval. Okay, let's do in the table. The table is not strictly necessary. I like to organize the work. One possibility is you take the 5 testing and plug it in one by one in the original inequality and verification, but it's, in my opinion, it's a little bit long, and maybe you will make a mistake. And remember, it's not important the value, it's important the sign. So you estimate using your common sense. The ordering is totally randomly. You copy any factor separately. Don't forget attach extra column. Okay, the testing was -2. I evaluate any factor. -1/2, I evaluate any factor. +1/2, I evaluate any factor. And 3/2, I evaluate any factors. We have one more. And 3. Cool. This is super easy. This is look like a game. Play a game. This is minus, this will be right. This is -2, -2 is minus. This is minus again. This is minus, and 4 minus is positive. This is minus, this is minus, this is minus, this is plus. It's -1/2. It's +1/2. So this is minus. The reason it's minus is because you have 1, 2, 3 negative. 3 negative is odd number of negative is negative. Even number of negative 1, 2, 3, 4 is positive. 1/2 is positive because it's +1/2. It's negative, obviously. It's negative and it's positive. 2 negative is positive. 3/2 is positive. It's negative because 1.5 is smaller than. But here is positive. Here is positive. 1 negative is negative. And 3, I suppose everything is positive. Not always happen, but in this case happen. I forgot that I come back to the beginning. At the beginning say that my expression that I try to investigate would be greater than or equal to 0. So in other words, greater than or equal to 0 is equivalent to say to be positive or 0. Okay, now the true guys is this. Is this. Is this. Okay, now this is a crucial moment in which you highlight. So the interval and what below -2 is this. Pass. The other interval is -1/2. No, +1/2 is this. Pass. And the other is 3 pass. Okay, of course, you extending from the critical value to the, in this case, to infinity, no? Infinity in that direction, infinity. So now we almost finished, and the super important detail. Inequality. Normally, in polynomial inequality, when it's greater than here, you include the endpoint. Here is similar, except that no 0 of the polynomial at the bottom. So you include the 0 of the polynomial at the top, que 0 and 2. So this is bracket here is 0, and this is bracket and 2, and the rest no. Parenthesis and parenthesis, because it's the 0 of the denominator, and you know that the 0 of the any denominator to be undefined. Solutions. So what is my final answer then? My final answer is then, copy here. My final answer is then -infinity, comma -1, parenthesis, no include, union. We have 3 pieces. We need to connect in these 3 pieces by union, bracket 0, 1, parenthesis, union, bracket 2, +. Boom, final answer. Any question? Clear or confusing?
Clear.
Tell me. Everything is clear? Sure? Okay. But not always is happy, because I give you one extra job. The extra job was Okay, I manipulate algebraically this guy and factorization. Suppose in the, in the real life, we have a more complicated inequality, Let me show you, I can erase the board or no? No? Yes?
Yes.
Okay, cool. Let me try to do this. Okay, es classical example of the solution rational inequality. Suppose 1 over x minus 2 less than or equal 2 over 3x minus 9. Something like that. Wow. At the beginning, it looked like easy. But actually, it's not easy. In my opinion, I respect another opinion. Okay, classical mistake. Some people believe, okay, this is equation, okay, it's equivalent to equation. And why not apply cross multiplication and that's it, end the story. No, this is wrong. This is completely wrong. Suppose you are doing this. What sign you put? What sign you copy when you apply cross multiplication? You copy the same sign or you reverse the sign? I have no idea because I know, okay, see, every multiplication is positive. Is stay the same. However, see, every multiplication is negative is reversed. To say I don't know because we are finding the value of the x. I don't know exactly if it's positive or negative. But this is completely wrong. Mistake, big mistake. And remember my word. To solve an inequality like that, you need to express the rational expression in the right hand side must be 0. This is the key idea to start. Okay, so you see somebody doing different, he has a big trouble. Okay? Okay. Let me try to find another example. No, it's okay. I don't find that. Okay, let's do that. So now you copy 1 over x minus 2 minus 2 over 3x minus 9. Bring it down or equal to 0. So the only thing I did was moving 2 over 3x minus 9 to the left. And in order to guarantee the famous 0 in the right hand side. Okay? Important, extremely important. After that, well, to this problem look like similar to the problem that we are doing before, you need to condensing these two fractions in only one compact rational expression. So you condensing in only one radical, not two radicals separate because this is crazy. Because you need to find least common denominator. But to find the least common denominator, first of all, you need the factorization of any expression in the denominator. In this case, this is impossible, but this is possible. The greatest common factor is 3, x minus 2. Okay. Now, LCD obviously is 3, x minus 3, x minus 2. Remember the rule. The rule of the LCD is you take every factor, no omission, any factor. It's only when something is repeated, you take the majority of them. But in this case, nobody is repeated because you take x minus 2, you take x minus 3, and you take 3. And you now allow you put a long line in which you put on the bottom the LCD. In the top, well, the top, let's do it. You remember, you divide this, divide by this, division, and multiplication by the corresponding numerator. And you have in the fraction. Let me explain it. You have LCD. You have denominator and numerator. And I suppose I want to find one expression that is equivalent. When you are doing this division, equivalent to this. You divide this divided by this division. You divide LCD divided by denominator. And this result multiplication by the corresponding numerator. And you get this expression. Give me the formula to this question mark. So basically, you divide, very easy because mentally you are doing, look, you divide LCD divided by x minus 2, it's obvious que cancel out x minus 2, and stay alive 3 times x minus 3 times 1, entonces 3 times x minus 2. Minus, this minus is this. And when you divide the LCD again by denominator 2, que es this, 3 is cancelled, and x minus 3 is cancelled, and stay alive only x minus 2 times 2, 2 times x minus 2. Everyone follow me? Do you understand the algebra I am doing?
Yes.
Okay. Now, you distribute the baby algebra and combine later. 3x minus 9 minus 2x plus 4 over 3x minus 3 x minus 2. Remember this line I apply to indicate in your moment this division something, but no, stay, of course stay. Entonces now you combine like term, of course. Entonces es 3 minus 2 is 1x. Oh, nice, I like. And negative 9 and positive 4 is negative 5. Over 3x minus 3, x minus 2. Less than or equal 0. Cool. Okay, look. This inequality we start at the beginning and nobody understand. Nobody is crazy. You using auxiliary algebra, we manipulate and you obtain not two fractions separately. No, only one. And one side 0. Okay. Entonces now we analyze using the same procedure, critical value, testing point, table, blah, 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 blah. Now, let me ask you a question. What about 3? This 3 we can delete or no? Let me know. This 3 is I can delete or no? Let me know.
Yes.
Yes. Why? What is the reason I can delete?
Positive.
Exactly. Because it's positive. But any positive do not participate in this game. And the game of the inequality, the important guy is the negative. Because the negative change. Suppose that everything is positive, 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 positive. Entonces no, nothing change. One negative or two negative, entonces change completely the situation. Okay, entonces this is important. I am closing the box because I am focusing 100% for solving this inequality. Entonces you find the critical value top. Critical value top is x minus 5 equals 0, x equals 5. Critical value bottom is x minus 3 equals 0, and x minus 2 equals 0. Is x equal 2 and x equal 3. And this is the correction of the our critical value to help me to create the partition in the all real number line. Suppose this is my famous all real number. Guys, I need to see in the test the solution. The solution consists one algebra. One part, the first part is algebra. Algebra, I call algebra accommodation. The second part is graphic. And the third part is a table. Three part I want to see in the solution. Some students don't understand, never understand this. I believe in solving write in the piece of paper only using algebra You can do that, but it's super complicated. And the student don't respect the equals, the less than sign, and believe que es equal, no, 0. So now, this is my famous Orion number line. Okay, the critical value are 5. 1, 2, 3, 4, 5. One partition. 3 and 2. Sorry, this is 2. And this is 3. Let me make a zoom to see much better. 3 partition, 4 interval. Let's select the testing point, maybe 0, fantastic, I like it. In between 2 and 3, 2.5. In between 3 and 5, 4, why not? And after 5, 6. 7, wait. Okay, now table. The table is always the same format. Table has one first column, que is the testing point. You copy 0. You copy 2.5. You copy 4. And you copy 6. And in the column, okay, we come back again. We have 3 factors. In either order, guys. X minus 5, X minus 3, and X minus 2. And 12. The format for our table always the factor, the relation of the factor, and the column, testing point. And we study in detail now the signs. Sign is too easy because you're blowing in one by one. 0 here is negative. 0 here is negative. 0 here is negative. 3 negative, negative. 2.5 es obvio que es negative. 2.5 es obvio que es negative. 2.5 es obvio que es positive. No? Yeah, positive. 2 negative positive. You follow me or no? Do you understand where come from this negative, this positive? Or no?
Yes.
Yes or no? Yes. 4 is negative. 4 is positive. Is positive and negative. 6 is positive. Positive and positive. Now I'm going to find what is true or what is false. We come back, not exactly in the beginning. No. You come back to this expression. The expression can enclose in the box because this is important. Yeah, it's important for 2 reasons. Reason number 1 is equivalent 100% to the original inequality. And number 2, it's easy to analyze. Okay, so now I see que the symbol here is less than or equal to 0. Okay, entonces es equivalent to say that the true guy is the negative. But that depends on the problem, no? Sometimes depending the nature of the inequality, si es greater than, is positive, the true, si es less than, is negative, the true. So the true in this case is this and this. Okay, ready to highlight? 0 interval, true. And 4 is true. Of course, extending from 3 to 5 get the endpoint. And 4 was one guys help me to analyze the behavior. Any point in between 3 and 5 have the same behavior. What about the endpoint? Include, no include, I don't know. Well, okay, it's included because it's less than. When you see less than, wow, unbelievable, it's included. But only include the critical value of the top. The bottom never. The include is the 5. And the rest no. No. Okay, then, 5 bracket. And the rest parentheses. 5 bracket, and the rest parenthesis and parenthesis. What is my final answer? The final answer is from negative infinity, comma 2 parentheses, union, parenthesis 3,5. 35 include bracket. Final answer. Cool. I try to find, but I don't find one special cases. Yeah, I suppose I write down here. I don't see. Don't worry too much because I have another extra paper here. Not too much. I have more, but I don't know exactly. I put. Let me try. I suppose it was in this paper. No, I don't see. Okay, no problem. So another page, another package I have in my hand now. Let me see. This is good, super good. Okay, another example. Let me show you. I like this. This, let me see. Okay. Oh, nice. I found another, not exactly they want. It's okay. It's okay, it's okay, it's okay. Cool. Any no question? Do you understand very well this? This is easy for you? Wow, you are good students. Wow. Because some students confuse a lot with this. Don't understand very well this. One more similar to this. Can you guide me? What should I do? Suppose this. Look like easy. What should I do? What should I do? You cross multiply?
Set the right-hand sign to 0.
Exactly. Entonces, you move this guy to the other side. Like that. Like that is okay? This idea is correct?
Yes.
Excellent. Now, what should I do now? Because I am confusing. What should I do? What should I do? We have two fractions separate. No, no, no. Two fractions, no. I need to only one fraction. What should I do? What should I do? You don't give me detail. You give me action. Professor, you do something.
We have to make it into one radical by finding the least common denominator after factoring.
Okay, cool. She said radical, not radical, it's rational. Fraction. Radical is something like that. No, it's okay, it's okay. Now, entonces, in your opinion, Miss, what is the LCD? So she said, okay, we need to condense these two fractions in only one, correct? Because nobody can analyze like that in two different fractions. You condense, put together. To put together, the classical idea is you find the LCD. Okay, LCD is, who is the LCD? Who is the LCD? No idea. You remember, you don't remember LCD. Come on, guys. Let me see that then. Okay.
It would be x minus 3x plus 1.
Both. You take both. Yes, you're right. What's your name? I need to know your name. Remember, the participation is important for me. Okay, so what is important? Suppose that when I compute the overall score, you get 85. 85B. However, if you are doing good participation, maybe the greater than 85 is 86, 87, 88, or 89. I consider B. I consider A, sorry. Okay, because she's good. He's good. Or he is good, depending the gender, no? I don't care the gender, right? I care. She say que es x minus 3, x plus 1. Uh-huh. Everyone is agree or disagree? Agree or disagree?
Agree.
Agree. What your name is?
I'm Jenny.
And Jenny?
Jenny Macy Rodriguez.
Jenny. Jenny, what is your last name?
Macy Rodriguez.
Rodriguez. Okay, this allow me put the long line, and you put the LCD. Entonces, in order to find the top part of the fraction, you divide this divided by each. Remember the formula. LCD divided mentally by denominator 1 and multiplication numerator 1. LCD, because we have two fractions, no? Divide now by denominator 2 and multiply by the corresponding numerator. One by one. So you have two fractions, you have three fractions. When you divide LCD divided by the denominator 1, this guy, this is LCD divided by denominator 1. Es obvio que x minus 3 cancel, no? And stay alive, x plus 1 times 5. Minus, because it's minus here. 3 times the other factor gets x minus 3, no? Yeah, because x plus 1 is cancelled. Stay alive, x minus 3 times negative 3. And don't forget the right hand side, because we are solving. Actually, we are manipulating expression. However, this expression is part of the inequality. An inequality or equation contain always have equal sign or greater than sign or less than sign. Okay, now distribute and combine. In you distribute, we have 5x plus 5 minus 3x plus 9 over x minus 3 x plus 1 greater than 0. And we combine. How we combine? Well, we combine 5 minus 3 is 2, and 5 plus 9 is 14, no? Over x minus 3 x plus 1 greater than 0. Well. In this case, I don't enclose the box because I prefer factorization. I see que 2 and 14 is their common factor, que 2. You factor out to x plus 7, right? And what do you think about 2? These two delete or not?
Delete.
Cool. And this is my impression. Okay, I dedicate all my time analyzing this expression. Okay, guys, it's important. At the beginning, give me inequality totally disorganized, crazy. Okay, you move everything to the left. You apply algebra, accommodation algebra. In this case, least common denominator, something because it's a rational. And the cake is not rational, the polynomial, when you are doing just the factorization, the polynomial. Okay, now let's compute the critical value. Critical value in the top is negative 7. And critical value in the bottom is 3 and negative 1. And these 3 critical value is using to make a partition of the organ graphic part. Okay, infinity positive, infinity negative. Zero always in the middle like a reference, no? To see the distance. Negative 1, easy here. Positive 3, 1, 2, 3. And negative 7 is 2, 3, 4, 5, 6, and negative 7. Partition here, and partition here. Actually, we have 1, 2, 3, 4 interval. Select the testing point. Maybe negative 8 is super good. Represent one citizen living in this country. What country? This country. Okay, of course, this country is standing. Maybe I'm using this tool. Let me see. Green. This tool allow me to do the sketch and after erasing automatic. Okay, no automatic. Give me a point. Okay, one more testing. Who help me with the testing, guys? Because I always select the testing and you not participate in this game. What testing you recommend me? And remember, you recommend me any que belong to this interval. Go ahead.
Testing point 0, 4, and
0.
the same -5.
Eso, bueno, mucho. Negative 5 and 2, 3, 4, 5. Everyone is agree with this testing point?
Yes.
Excellent. So I create my table using this testing point. Testing point. Negative 8. Negative 5. Sorry, it's a negative, no? Hello. 0 and positive 4. And what is the factor involved in the problem? Oh, wow, that factor. And in the order is not important. Okay, this table looks like horrible. The line is not good for me. And 12. Okay. I'm plugging in one by one. That's super easy. What is advantage and disadvantage? Maybe it's too long. However, disadvantage, you plug in negative 8 here, negative 8. This is a little bit. You put in the calculator, maybe. This is a negative, this is a negative, and this is a negative. And 3 negative is negative. And negative 5 is negative 5 is positive. And this is negative, and this is negative again. It's positive. Okay, I like that. 0 is positive, 0 is negative, and 0 is positive. Negative. And 4, everything. I come back to my inequality. My inequality is greater than 0. It doesn't matter if it's equal or no. This is equivalent to understand it's positive. And the true that the testing point get past the test was the positive. It is a negative 5 that belong to this interval. And 4 that belong to this interval. And this interval, remember, start and 3. Okay, the endpoint is negative 7, negative 1, and 3 is coincident perfectly with the critical value. No? Okay, now, my inequality no contain equal sign. Therefore, any endpoint belong to the solution. No, and no. And the final answer is minus 7 comma negative 1 union 3 comma infinity. Oh, cool. You understand very well the endpoint idea? And only in the rational, see we have equal sign here. Negative 7 is bracket. Pero no, professor, no, don't change the problem. The problem original have no equal sign. The no equal sign does mean any endpoint belong to the solution. Only the point in between the endpoint belong to the solution. Clear?
Yes.
Okay. Entonces I have one more. No, let me see. Yeah, I have. Okay. Another specimen. Okay, suppose this. May I erase the board?
Yes.
Yes.
Okay. But I need help because I am confused in that part. 6x minus 5 less than 6 over x. Wow, what is the hell is that? Yeah, you can multiply everything by x. This is wrong. Cross multiply.
We have to set the right hand sign to 0.
Exactly. Okay. So you multiply everything by x. Of course, you eliminate the fraction. It's a classic in algebra. However, you don't know if x is positive or negative. Therefore, you don't know if this sign stay or switching. Don't flip it. So this is this idea is completely wrong idea. Again, the same strategy. 6x minus 5 stay here, minus 6 over x less than 0. This is important thing. Must be 0. Okay. After that, what should I do? Because in this problem it's complicated because we have fraction and no fraction. Another problem, we have fraction and fraction, entonces it was easy because you find the least common denominator, no? Entonces you condense in only one, but in this case I don't understand very well. What should I do? Help me. Nobody can help me? This is algebra. This is algebra, accommodation algebra. Algebra for accommodation. Remember, my goal is express it like a one rational fraction. So you have polynomial, no? Less than 0. This is my goal. Okay, my goal is put together somehow. Nobody have idea? Tell me, please. You find the LCD or no? What is the LCD in that case? What is the only expression that we have in the denominator? X. So why no? You can condense everything using x que es de our LCD because we have only one x. That the expression, the only expression that we have in the denominator is x. So es x, entonces this guy have no denominator. Yes, it's a whole number of S1. X divided by 1 is x times 6x is 6x squared minus 5x minus 6. Make sense of this one? Let me erase that part, because maybe it's confusing. Do you understand the thing I am doing or not?
Yes.
Eso, bueno. Now, well, the professor always explain before enclosed in one box, we need to factorization. So I need to do my best. Try to do the factorization this trinomial. No? Okay, this is easy. This is 36. I multiply 6 times 6. Remember, I don't care the sign. The sign is not important. And find the combination to open the door of the factorization of 9 and 4. Because 9 times 4 each other give me 36 and 9 minus 45. Okay, suppose that this combination work. Therefore, you copy the first exactly the same. You split 5 using 9 and 4, and the last 6 stay the same. Do you understand the idea that I'm doing? Either way, there are many ways to do this. This is the thing you learn in intermediate algebra. The teacher explained that method or another method. Now, the idea was you convert trinomial 1 to 3 and polynomial 1 to 3, 4, and you apply factorization by grouping now. The great common factor in the first couple, que es the red couple, is 3x. And we have 2x minus 3. And the great common factor in the second couple is... I make a mistake, no? Yeah, I make a mistake. It's a plus, right? Because negative 9 and positive 4 is negative 5. Okay. So the great common factor is 2. Is 2. And we have 2x minus 3. And 2x minus 3. And inside the last parenthesis, we have 3x. This 2 is this. Okay, cool. Now my expression is 2x minus 3 over 3x plus 2 over x less than 0. Oh, and this is the important key enclosed in the box, because now we start now the problem. The rest was algebra. Que I know que some students don't understand very well, no? And this is your problems. But the important part in pre-calculus is this analysis is coming now. Okay, now. You compute the critical value of the top, que es, you take 2x minus 3 equals 0. And 3x plus 2 equals 0. Okay, you solve these two linear equations, super easy. 2x equal positive 3 divided by 2, 3 half. The first critical value is 3 half, 1.5 in decimal. 1.5. Okay, that's good in decimal because when you are doing the graphic, you see more clear the position. And the second is 3x equal minus 2 divided by 3. X is equal minus 2/3. Que en decimal is negative 0.6 repeated. 6. And the critical value in the bottom. In the bottom we have just x. It says x equals 0. Don't necessarily do anything. Okay, ready. To using that value, make it partitions. Infinity, negative infinity. We make a zoom. Oh, in 0 we have partition. We split this in two parts, positive part and negative part. Now, in the positive part, we have 1.5. 1.5 is located here. 1, 2, in between 1 and 2 in the middle. 1.5. 1.5 critical value, 0 another critical value. And negative 1 here in between and between 0 and -1, close, a little bit close, not too much, but in the middle 0.5, here is negative 2/3 or negative 0.6 repeat. Okay, okay, okay. What should I do? Take the testing point. I want to recommend testing point. I don't want to ask you what is the testing point. I recommend. Well, I recommend -1. Okay, the idea is in between this interval you take -1, -2, but I recommend close to the critical value, no, close to the critical value. And between negative 0.6 and 0, you can take negative 0.5, 0.3, or negative 1/3. Either way, in my paper, I take here negative 1/3. It doesn't matter. In between 0 and 1.5, obviously 1. And after 1.5, 2. This is my testing. -1, -1/3. Guy, arbitrary. The answer doesn't change if you select different. Because remember, this is interval. We analyze interval. Let me use a rule, guy. How many columns? How many columns we have? We have 1, 2, 3, 4, 5. One more. Is ID igual o no? TP. Vertical line is easy for me doing. We have -1, -1/3, 1 and 2. One more. What's going on? One and 2, no? The factor involved in my problem was 2x minus 3, 3x plus 2, and x. And total. Okay, do it. Okay. -1 is obvious que es negative. Here and here. 3 negative. Should negative. 1/3 is negative. Yeah, is negative. Negative something minus negative something is negative. And 1/3 negative is positive. Why? Because 1/3 times 3 is 1, -1. And -1 plus 2 is positive 1. And here is negative, so we have 2 negative is positive. 1 is negative. 1 is positive. So the 3 plus 2, 5. And positive. 1 negative is negative. And 2 is positive. Positive and positive. Okay, we come back again to our original problem. And the original problem says is less than 0. Because the true is the negative, guys. Es the interpretation, dice. Okay, ready, to be ready. This is negative. It's true. And this is negative, that's it. The rest is no, the false. I don't care the false, I care the true. It's the solution for the inequality, no? Entonces highlight, what part highlight? Highlight -1, que es this interval. Stop here and 2-term. This point, remember, was negative 2-term. And one more is true. One more is true, and 1. This interval is extending from 0 to 1.5. This is 1.5. 1.5 was 3/2. So the answer, the final answer you write, es obvio que this inequality que have no equal sign do not include the endpoint, the parenthesis, and parenthesis. Remember, when included, when it's equal, include only the critical value at the top, never the critical value at the bottom. No. And when it's polynomial, it's no fraction, include everything when it's equal. Okay, so what is my final answer? My final answer is then. Answer. Bam. Is from negative infinity, comma, negative 2/3, que es this interval, union 0,3/2. Bam, finals. Finals. Okay. One more of this, or similar. Are you bored, guys? Are you bored? Everything is okay? You follow me?
Is it okay to put the answer in decimal form as well?
Doesn't matter. Yes, good. The way you prefer. Okay, one similar, but you help me. I have 2 more examples, and that's it. I have more, I don't know. So to use, you consider que es too easy for you, entonces stop. X over nothing. X plus 12 over X less than or equal to 7. This is the original given problem. What should I do? Any help? Come on, who there? Participation. Come on, Edward, Joshua, Andres, Angelo.
Gotta set it to 0.
Say again?
Set the right-hand side to 0.
Is it Jenny, no?
Yes.
Jenny. Edward, you say something?
Yes, the right hand side needs to be 0.
Eso, bueno. Okay, entonces I do, and you correct me if I make a mistake or not. It's okay? I did well?
Yes.
After that, what should I do?
The least common denominator.
And what is the least common denominator, miss?
X.
X. So you put a long line, you put X. And the top you put X squared, making sense, right? Plus 12 minus 7X, something like that, correct?
Yes.
And yeah, enclosed in the box, this expression is the best I need to analyze or no? What should I do now? Well, first of all, I propose you one idea. Organize the trinomial on the top like that. Always you organize in descending order of the degree, degree 2, degree 1, degree 0. To see more clear, it's the language of the algebra, no? And let's do in the factorization, right? Of this polynomial. We do parentheses. The variable is x, and the combination can open the door obviously is 4 and 3, no? So 4 times 3 is 12, and 4 minus 3 is plus 3 is 7, and negative both sides, correct? And this is the expression that enclosed in the box. You see, guys, it's unbelievable. Look at this ugly inequality that nobody understand very, very well. Now it's clear. Everything is clear, right? What is the next step in the procedure? What is the next step? Come on. Next step.
Critical values of top and
Critical
bottom.
value. Cool. Critical value top and critical value bottom. What is the critical value top and what is the critical value bottom? What do you consider the critical value?
X equals 4, X equals 3 on top. And then just 0.
Cool. It's a critical value. Entonces, ¿en what part are you using the critical value? What is the next step?
Create the number line.
Number
All
line.
those lines.
All real number. Okay, ahí está. 0, partition. 1, 2, 3, partition. 4, partition. What is the next step?
Pick
Test.
points.
Exactly. Help me to select any testing point that you consider good.
-1.
I like that. One more.
1.
One positive.
Yes.
One
And
more.
3.5.
3.5. Cool. And one more. No more.
Oh yeah, 5.
That's it.
Wait.
And what about the interval after the 4?
5.
Remember, the mnemonic device, to remember that is clear. You have 3 partitions. These 3 partitions split the all real number line in 4 intervals. And you need to select one totally arbitrary testing point inside each interval. Okay, now create the table. Keep it. You listing the testing point. -1, +1, 3.5, and 5. And you copy the column corresponding with the factor in our expression, que es x minus 4. It doesn't matter the order. X minus 3 and x. And you condensing the sign information in the last column que I call total. Okay. And the rest is just plugging in. Negative, 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 and negative. Negative again, negative again, positive. Okay, positive. 3.5 is negative, is positive, and positive. Is negative. And 5 is positive and positive. According to our problem, less than or equal to 0 is equivalent to C negative. So the negative, guys, in the last column is the true part. It's true here. And it's also true here. Okay, it's a crucial moment in which you highlight that interval. and highlight this interval. Okay. Be careful now with the equal because our inequality contains equal sign. Therefore, the critical value in the top case, this guy, belong to solution. And the symbolic way to indicate this idea is using bracket, 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 and here no bracket. So my final answer then is answer, 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 answer. From negative infinity, comma, 0, pero no incluye 0. Union, bracket 3, comma, final answer. Cool?
Yes.
Okay, super. No question. Okay, I want to cover another kind, a little bit, it's similar. We can apply the same idea. But in my opinion, it's easier, but it's tricky. It's another inequality que is not only one, sino compound. It's three-part inequality. Pero three-part inequality rational. Okay, this is the challenge. Let's bring this example. Let me see what is the best example to start. This is good. Suppose this. 0 less than 4 over x less than 2/3. Wow, professor, you never explained this. Well, okay, I understand. I never explained because I explain only one inequality, like that. In this case, you know very well what should I do. But in this case, it's three-part inequality. And when it's no rational like that, you solving easy. Suppose you have, I don't know, 10 less than 5x less than 25. Oh, I remember very well. Divided by 5, divided by 5. Entonces 2, and this is 5. And that's it. There's an interval between 2 and 5. Okay, it doesn't matter. Que include 2, include 5. Si es equal, include both endpoints. Si no equal, no include. Si es equal and 1, include 1, and another no. This is the way that you are doing frequently in the other algebra before this algebra. But now the new challenge is we have rational because the variable is located in the denominator and also a three-part. Wow. And what should I do? Well, I propose one fantastic idea. Look, why not split? Why not you split this and this inequality? And you split this and this inequality. I copy. 0 less than 4 over x. I copy separately in one side of the piece of paper 4 over x less than 2/3. Bueno, professor, pero this is equivalent. Bueno, es equivalent si you connecting this by. So basically, you convert the three-part P, three-part inequality. Wow. Three-part inequality. And one compound inequality. And how do you know que some, professor? I know or. Because sometimes in the other algebra, we study and or, no? Because it's obvious that you need to satisfy the red condition and green condition. So you need to discover what is the interval, the common, the part que touch, the part que overlap, the red part when they solve it. So you split the three-part inequality in one compound, and the one compound contains two parts. You solve it separately now, and in the last moment you put together in the number line using and. And is intersection. Okay? And is intersection. Okay, let's do it. So now I write vertical line que split one problem y another problem. Let me solve this first. Doesn't matter the order, but this is more understandable. This is more complicated. This is more complicated. This is easy. Okay, okay. Well, you say, bueno, professor, you move to the other side because right-hand side must be 0. You can do that. You can. You can do that. However, they are shortcut. However, they're shortcut. You flip it that and you flip it that. You copy x over 4. And you copy 3 over 2. So the only thing I did was find the reciprocal of this and find, and we can do that when it's monomial expression, no? And when you are doing this action, when you flip it, it's obvious that the sign is flipped, reverse. Makes sense or no?
Yes.
Entonces I feel more comfortable because now the x is located in the numerator. And if you want, you can apply cross multiplication because basically any number is positive here, right? Multiply 2x greater than 12. In this case, yes, we can. We can. And the answer is obvious, it's positive. It's totally a stupid belief if the x is negative because it's negative divided by positive is negative and this is positive. So it's obvious that x is positive. So you can apply or another algebra. You multiply by 4. Let's do it in a different way. Finally, you divide by 2. X greater than 6. And this is the answer. No, it's a one piece of the answer. It's a one piece of the answer. Suppose que another student say, well, okay, you teach me, professor, que you, for example, you move this to the other side. Okay. You respect the right-hand side 0. And you find the LCD gets 3x. And between 3 and x. Entonces es divided by this is 12 minus this divided by this is x 2x. And you now find the testing point, but no. You see that this is easy. I try to illustrate both ways, but this is easy. This is easy. Another possibility is you multiply, no cross multiply. I hear cross multiply. You say, you believe. To say you multiply by 4 here and here. It's obvious that the 4 is cancelled. And this is 12 over 2 is 6. And it stays the same sign. Because you are multiplying by 4. 4 is a positive number, therefore the inequality sign stays the same. Make sense? What the hell? So one piece of the information. The second piece, I go to this. Okay, this again, I don't feel comfortable. I don't feel comfortable when the variable x is located in the right hand side. No, never. Any inequality I solving, you solving like that. You have, for example, suppose you have 4 is equal to 2 plus 6. I don't feel comfortable. Oh no, less than. I don't feel comfortable with the x's in the right hand side. And the equation, yes, the equation is nice because the equation you're moving and nothing happened, but when you moving here happen, right? So suppose that you interchange, you put 2 plus x here and you put 4 here. Now the sign is also reversed. It's flipped because it's classical. No, suppose that you have, for example, 5 greater than 4, and you put a 4 here and 5 here. It's all because like that. No? So there are two reasons in which the manipulation of the equation you need to flip it the inequality sign. Reason number 1 is the most important, is when you multiply or divide by negative. But reason number 2 is when, for some reason, I don't know why, some reason, you need to interchange. Let's suppose you put here 4 over x, you put 0 here, it's obvious that this sign stay here. Make sense?
Yes.
But again, the same stupid thing I don't understand very well is when the x is in the bottom, what should I do? 13 point critical value. No, you apply common sense. Common sense is important, right? Common sense is when you apply it right, of course, common sense. But this expression came close in the box. It's positive. How do you know? Because it's greater than 0. Yes or no? Therefore, I know using my eyes that 4 is positive. Therefore, this is equivalent to say that x is also positive. Make sense? Do you see or no? No? Confusing? Come on, honestly, ask me. Yes, no, no. What happened, guy? Are you tired? Too much, eh? 2 hours. And Wednesday, we start the big review I prepare for you. Cover everything at the beginning. Okay, don't. Important day, Wednesday and next Monday. Okay? So you understand the thing I do or no? No?
Yes.
Okay. Now, you put together this and this using and. Okay, let's do it. Let's do it. This is my old real number again. Okay. This is infinity. This is negative infinity. Okay, we have 0 here in the middle. 1, 2, 3, 4, 5, and 6. If you want to analyze the and conjunction, the union, no, sorry, the intersection. Let's do it first, this part first. Okay, this is from 6 in the right direction. Yes or no? I put it like that and not directly highlight on the number line because this is the roughly sketch to understand the intersection. And the second guy is this. I'm using another color. Okay, this color. This guy is from this 0 to this. Yes or no?
Yes.
Okay. Now thinking, because it's tricky, what is the intersection between the red part and the green part? Intersection means common element, common number. What is the common number that share the interval between 6 and infinity and 0 to infinity?
6.
6, very well. So let me select another color to don't confuse in gray color maybe. The answer is that part. Yes or no? Do you see the idea or no?
Yes.
Include 6 or no? Parenthesis or bracket?
Is it parentheses because there's no equal?
Exactly. Because the no equal automatically, you know. So what is the answer? The answer is bam, 6, infinity. Do you see that? One more, guys. The last one. I promise. I promise it's the last. 3-part inequality. Three-part inequality. Suppose this. I put the no super hard, but confusing. Tricky. That's the word. Tricky. Look. 3-part inequality. It's a typical inequality that contains 3 parts. One is 0. Another is un paréntesis, 2x minus 4. Raised to the negative 1. Wow, what the hell is that? And 1/2. three part. It's weird because it introduced a new idea que es raised to the -1, pero you know very well que -1 is equivalent to say reciprocal, to say 1 over 2x minus 4. More clear now, at least for me. Entonces we are doing exactly the same. We split into part, that part. We split into part. I know very well. Okay, we connect in by because it's three part, and you need to satisfy this inequality and this inequality. So always three parts and guys, never is or. Never is or. Okay, entonces now ready to manipulate both parts separately, completely independent. Let me focus on this. We can. If you want, you move the 1/2 to the other side and you convert to the classical inequality we are doing before, factorization, critical value, partition. But no, you are doing shortcut. And by the way, you get the same answer. You can flip it both. So you write like that, 2x minus 4 and 2. But the thing I did was flip it that. And when you flip it that, obviously this sign is switching. Wow. And you convert now in one super easy linear inequality. Because the problem is solving the complicated non-linear, but this is linear. Linear is similar to the algebra 1. 2x greater than 2 plus 4 is 6. Divided by 2, x greater than 3. And this is my first piece of solutions. My second piece of solution, we are solving very similar to the thing we were doing before. Look, I don't feel good when the x is in the right hand side. No. Immediately I move to the left. 0 to the right, and you switching that. Okay, and now common sense. Common sense you apply always when there's 0. The common sense is positive or negative, no? So this expression is greater than 0. This expression is positive. That exactly this statement say that this expression is positive. One is positive, therefore denominator is also positive. This unbelievable but true. This is equivalent 100% to this. Okay. But this is look like complicated and this is super easy. 2x greater than 4 divided by 2, x is greater than 2. And this is my second piece of information. Es 2, ¿no? Es 2. Divided by 2 is 2. 2. I copied wrong on my piece of paper. Okay, now moving to the last part. The last part is last part is all random line. Okay. Okay, infinity here. We have infinity here. Okay, we have 0 here, not necessarily in the middle, because the value that I have in my problem living in the positive part, 1, 2, and 3. Okay, that part is here. And that part is here. And I need to find the and. And is intersection. And the intersection is obvious, at least for me. Let me know if you see or no. Get that part, no? Of course, no included 3. And the answer is 3, infinity. It's okay or no?
Yes.
Okay, guys, this is too much for today. Stop. Soon I create a video that I send to you by email. Okay, try to study. This subject is hard. You see it hard, right? It's not for the baby. And some student and my professor say, no, so you want to take baby class, don't take with this professor. Okay, okay guys, bye. Have a nice day. Enjoy your day. I will my day. Bye-bye.
Have a good day, Professor.